Who?
All right, I'm recording. I just want you to know that. So we're gonna get started. Y'all can talk about that later. I just don't want it to be recorded. All right. Sketching the graph of a polynomial function. I think this one is pretty much the easiest one because polynomials are easy to take the derivative of. So I'm not even really worried about the sketches anymore because you guys can do that on your own in your calculator, and I'm okay with that. All right, so when you get your homework, if you have been sketching it, just stop sketching it at this point, okay? Find those derivatives and do the chart. So find the first derivative of this function. What is it going to be? $36x squared.
Plus 96x.
Find the second derivative.
12x.
Keep going. Uh-huh. Good. All right, find your critical values. How do you do that? Take that first derivative, set it equal to 0. I mean, the second derivative, set it equal to 0. You can do the first derivative as well. The harder, it's just a little bit harder. So you can find it from either one. It's not going to matter. X squared minus 6x plus 8. I factored out a 12 from the second derivative. The 12 is not going to matter, so I'm just going to work with x squared minus 6x plus 8. What are your factors of 8 that add to negative 6? And I get positive 4 and positive 2. Now, the reason I didn't go ahead and do the first one, it is 4 terms. It's a little bit harder. If you want to find your zeros, you can do that on your calculator. So I just wanted to wait to do all the calculator stuff at one time. So 4x to the third minus 36x squared plus 96x minus 64. I just did a regular Zoom 6. There might be, your graph may be weird because it's got trig functions and stuff from pre-cal in it. So just letting you know. And then what 2 zeros do you see, or your x-intercepts? Well, we already have 4, right? So this is from f prime of x set equal to 0. But we only need one of them. These are from f double prime of x set equal to 0. So your critical values are 1, 2, and 4. So then your first interval is negative infinity to 1. We're going to look at what happens at x equals 1. Sorry, 1 to 2. We're going to look at 2. 2 to 4, we'll look at 4. And then to infinity. So again, the intervals on f of x do not matter. For f of x at x equals 1, we get negative 27. At x equals 2, we get negative 16. And at 4, we get 0. Everybody okay with how I found those? Because I taught that yesterday. Is everybody good? Okay. Again, you can just put f of x into your calculator and change your table to ask, and then put those values in. You're going to do the same thing for f prime of x. I already have that in f prime of x. I'm going to change my table set to ask. And then I'm gonna ask those values. Give me a value between negative infinity and positive 1. What? I heard 0. I don't know what else I heard. -1, -2, -3. It doesn't matter as long as it's less than 1. What kind of number does that give you? So less than 0. What happens at 1 is it gives me a 0. In the interval 1 to 2, I plugged in 1.5 and I got a number greater than 0. When I plugged in 2, I got positive 16. A number between 2 and 4 is 3, which gave me a positive number. When I plugged in 4, I got 0. When I plugged in a number greater than 4, I got 16. Yes. I was thinking about what I was doing next. So let's go through and talk about the characteristics. So what is the characteristic when it's less than 0? What about right here on the next one, next interval? When it goes from decreasing to increasing, what happens? A relative minimum. And where is that minimum at? 1, -27. Perfect. So then we get this 16. We're going to hold off on that because what happens here? It's increasing and then it goes to increasing again. So nothing happened there. What else? The last one is increasing. So we didn't have any more relative max or mins. Does everybody understand that? It has to change from increasing to decreasing or decreasing to increasing. We're going to check our double prime. 12x squared minus 72x plus 96. We're going to go in our table. What happened in this interval? Greater than 0. At 1, it is 36. At 1.5, greater than 0. At 2, it is 0. On the interval, it is less than 0. At 4, it is 0. And on the interval, it is greater than 0. So what happens on the first interval if it's greater than 0? 0. Concave up. What happened now on the next interval? So since that didn't change, there's no point of inflection. What about the next interval? Concave down. So what does that mean happened in between there? Point of inflection. Where is that point of inflection? It is to -16. The last interval is greater than 0, so that's concave up. It changed from down to up, so that means there's another point of inflection. And where is it at? 4, 0. That's it. Any questions? All right. The 4th degree polynomial above has one relative min and no relative max. In general, a polynomial function of degree n can have at most n minus 1 relative extrema and at most n minus 2 points of inflection. Moreover, polynomial functions of even degree must have at least one relative extremum. So even degree is like 2. 2 is going to give you that U shape, so it's going to have a minimum, or it's going to give you the N shape, so it'll be a maximum. So it'll always have at least one. Everybody good? Okay. Trig function. Again, I don't have to graph it. If you want to go back and graph it, that's fine. I'm not going to do that. So let's talk about our first derivative. How do we get our derivative of this? Crappy quotient rule. What do we do? What's the derivative of cosine? Times the derivative of the bottom. I'm sorry, times the bottom. What am I writing? Minus the derivative of the bottom. What's the derivative of 1 plus sine x? Just cosine x. Times the top. All over the bottom. Squared. We're going to clean it up and distribute our sign, so we get negative sine x minus sine squared x minus cosine squared x over 1 plus sine x squared. What do you notice? 2 things. Say it again. To what? To 1. Remember, sine squared x plus cosine squared x is 1, but they're both negative. So what should I do first? Pull out a negative. They're all negative. So I'm going to go ahead and take out a negative 1. And then your sine squared plus cosine squared changes to 1. So this gives you, I don't know where the sine went. Oh yeah, there. Negative 1 sine x plus 1 over 1 plus sine x squared. And now what do you see? Yeah, even though these are backwards, you can cancel one of them out. So your final is going to be negative 1 over 1 plus sine x. We're going to make it easier though. How can we make it easier? Yeah. So this is going to be your derivative. That's fine. But when I take the second derivative, I would do it to the negative 1 like this. So how would I find the derivative of this? Negative 1 times negative 1 is positive 1 times the inside to the 1 less power times the derivative of the inside. What's the derivative of sine x? Perfect. Then we just fix it. Cosine x over 1 plus sine x squared. Do we have any critical values? So do we have anywhere that negative 1 over 1 plus sine x would equal 0? How would I solve that? I ain't even trying to do that. How would I, just tell me your steps, like if I set this equal to 0, what they would be to solve it. Yeah, right. So I multiply it over. Does everybody agree with that? Cross multiply or whatever. Can Can -1 equal 0? So there's no critical values on this point, but there are values of this one. So we're going to take f double prime, set it equal to 0. We multiply that 1 plus sine x squared over, and that gives me cosine x equals 0. We're going to find where it equals 0. I'm going to change my window. 0 to 2 pi. I'm going to try pi over 6. I told you I always try pi over 6 because it's the smallest. And then I like to change these to -1 and 1 just so I can see it a little bit better. So it does go through. Where does it go through at? It'll be 3 pi over 2. All right. So I'm going to talk to you about this one for just a minute. These values you can restrict to any set of like 2 pi. So it could be -pi over 2 to pi over 2, as long as it's a full rotation. It doesn't matter. You could do -3 pi over 2 to whatever's on the other side, as long as it's 2 pi. So this one actually decided to go from -pi over 2 to pi over 2. So this one. Would you get it wrong if you did it from 0 to 2 pi? No, you would not. You would not. All right. They still use these values. Don't stress out about them. They still use those values. So this is what we have. They went ahead and started it at -pi over 2 because that was a boundary line. Does everybody understand that? So that's why this one starts with that and not an interval, because that is the end of the boundary line. Then they went -pi over 2 less than x less than +pi over 2. Then they checked it at pi over 2. Then they went pi over 2 to 3 pi over 2 and checked it at 3 pi over 2. And again, this is just what the book does. If you went 0 to 2 pi, it'd still be the same thing. Okay, so do not stress out about it at all. We don't check our intervals on f prime. I'm going to go ahead and tell you at -pi over 2, it is undefined. What does that mean? What is it though? Vertical asymptote. At pi over 2.
Undefined when you get an error.
Yes, yes. Pi over 2 is 0. And 3 pi over 2 is going to be undefined for all, which means it's a vertical asymptote. Very good. So we're going to do f prime of x -1 over 1 plus sine x. We're going to check our table. I need a value between -pi over 2 and pi over 2. 0. What do we get at 0? -1, so it is less than 0, which means it is Good. At pi over 2, it's -1/2. And then what about pi over 2 to 3 pi over 2? Think about it just without terms of pi. So 1/2 to 3/2. What's between what? Just 1 pi, right? So let's try pi. And we get -1, which is less than 0. What does that tell you? But what does it tell you? That we have 2 decreasing side by side. There's no relative extrema. There's no relative extrema. Does everybody understand that? So there's no max or min. When we get to f double prime, we have cosine x over 1 plus sine x. We can look at the same values. At 0, it is positive. What's that mean? Concave up. At pi over 2, our value is 0. And at pi, our value is negative, which tells you it is concave down. When I go from concave up to concave down, that is a point of inflection. And where is that point at? Perfect. Any questions? All right, trig functions. This is an inverse trig. Analyze and sketch a graph of y equals arctan x squared. So the first thing you're going to do is find y prime. How do I do that? So what is it? Perfect. Remember, these rules are the ones that we took the quiz on. We're going to put it together. And then when we set it equal to 0, I'm going to go ahead and tell you that you get 0. So there's one critical value. Y double prime. Sorry, y'all. Derivative of the top. So start with 2 arctan. What's your derivative? But also I have a what? 2. Times the bottom. Minus, what's the derivative of the bottom? Times the top. All over the bottom squared. How can I clean it up? Yes, they would. Whoever said it, they would. Good job. Very good. So that just leaves me with 2 minus over here. you're gonna have 4x arctan x over 1 plus x squared squared. And then the only other thing that they do is they take out a 2 in the top. If you don't do that, it's not a huge deal. Does everybody understand that? It's not a big deal. So take out the 2, you get 1 minus 2x arctan x over 1 plus x squared squared. When you set this equal to 0, and again, just trying to save some time for you guys, you're going to get pi over 4 and negative pi over 4. All right. I don't know why I didn't put the chart in here, but we're going to make our own chart. So your values are going to go from negative infinity to negative pi over 4, negative pi over 4 to 0, 0 to pi over 4, and pi over 4 to infinity. When the book makes your charts, they do it like the ones that I've been putting in. When I make them, I like them better like this. Okay, it's up to you and your homework, whatever you want to do. And then what I'm writing, f prime of x is what's going to come first. When I plug in f prime of x and I plug in a value, I get less than 0, less than 0, greater than 0, and greater than 0. What does this tell you? Less than 0 tells you greater than 0 tells you. And what did that row tell us? At, we know our x coordinate, right? What's our x coordinate? Zero, the one in the middle. So this is how I do it. I stick it right in the middle of them so I know that I'm dealing with 0. So how would I figure it out? Put in your calculator. How do I put arctan in my calculator? Is it 1 over or is it second tan? Okay, second tan x squared sorry. And in your table, put in 0 and what do you get? 0. Again, on your homework, I'm okay. Like it tells you to identify the relative min and max. If you just do that, I'm fine. Okay. All right. Then we do f double prime. I'm going to go ahead and tell you when you plug it in, you get less than 0. You get greater than 0. Greater than 0. And less than 0.
Michelle, I know this sounds stupid, but I'm a little bit confused on the mid and max.
What part are you confused on?
I just don't want to know how you know that's not.
Okay, so it goes from decreasing to increasing in the function.
Okay.
So that makes a what? I mean, that's the difference. So anytime it switches, so this went decreasing, decreasing, so it's a continual. It's the minute it turns to increasing that it becomes a minimum.
When would it be a max?
When it goes from increasing to decreasing.
Oh, okay.
That's it. All right, so on the second derivative, same concept. The first one is concave down, and then we went to concave up. When you see that going from concave down to concave up, you know that that's a point of inflection. At negative pi over 4. Our original function is n. I'm gonna put in negative pi over 4. And I get 0.44. Y'all, I'm good with these decimals, okay? I don't need you to give me the exact, it's fine. 0.4433. I just want to save you time. This one goes concave up. Since we didn't change from concave up to concave down, there's nothing happening there. But then we go from concave up to concave down, which means that there's a point of inflection. And that's at pi over 4. Which gives us the same value, 0.4433. Everybody good? All right. Come on. Again, if you make the chart like this, I like it like this when I'm writing it out. I don't necessarily like it the other way, but you can do it whichever way you like. Doesn't matter. Analyze and sketch the graph of ln x squared plus 2x plus 3. Remember that ln is u prime over u. I don't know that we've tested on that. So that's why I wrote it down. The other ones we tested on. So the u is everything inside. So what's the derivative of the parentheses? And then over the parentheses, which will be x squared plus 2x plus 3. Okay. If I set this equal to 0, I'm going to get that x equals -1. Remember, it'll cancel out the bottom. I would subtract 2 and divide by 2. You good or no? Promise? Okay. F prime or double prime x, how would I have to do it? Yeah, the quotient rule. So the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Distribute it out on the top. You get 2x squared plus 4x plus 6. When you double distribute on the top, 2x times 2x is 4x squared, and it's a minus. At the same time, 2x times 2 is 4x. 2x times 2 is also 4x. So we get 8x, but it's going to be a minus. And then the last 2 times 2 is 4, and it's going to be a minus. Clean up the top. We have -2x squared minus 4x plus 2. Over x squared plus 2x plus 3. And then what's the only other thing that they'll do? Not just a 2, but a -2. So x squared plus 2x minus 1 over x squared plus 2x plus 3 squared.
Yeah, away from the derivatives here. Or is it like that when you-
When we do integrals and we do antiderivatives.
Huh?
When we do integrals, it's like backwards derivatives. No. That's the answer to that question. All right, is everybody good with F double prime? I need to set it equal to 0. I would set the top equal to 0 because the bottom's going to cancel out. Do I have any factors of -1 that'll add to 2? No, so guess what I get to do? How do you solve something that's unfactorable? No, we ain't got to do it along with it.
Not gonna say it loudly.
Think way that quadratic formula. Quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. Your a, b, and c come from your numbers. It is 1x squared, so a is 1, b is 2, and c is -1. So -b is -2. B squared minus 4 times a times c all over 2 times a. Put in what's underneath the radical without putting the radical in your calculator. So just the underneath. And that will give you 8. So -2 plus or minus square root of 8 over 2. And then you need to break down 8. You're going to prime factorize it and you get 2 times 2 times 2. Pairs will pull out. That's the same thing as the square root of 4. What's the square root of 4? 2. So that's where that 2 is coming from. So we're going to have -2 plus or minus. I pull out the 2. I left a 2 over 2.
Think you can't start school.
Just the 3 in the front. So I talk about the triangle of numbers. So if you had me, that's what I said, triangle of numbers. So you would get -1 plus or minus the square root of 2. You do not need the 2 on the bottom or the 2 in front of the square root. It's like having a 1 in front of an x. It's pointless. All right, is everybody good? So don't forget that I had the x equals -1 at the top. So your 3 critical values or your 3 numbers that you're going to put in your chart. -1 minus the square root of 2, -1, and -1 plus the square root of 2. How do I know what order to put them in? I put them in my calculator and I look down. Does everybody understand that? So this is the order that you're going to put it in. -1 minus the square root of 2 is -2.4. -1 plus the square root of 2 is 0.41. So I'm putting those up there so that we know what values to plug in for F prime. I'm gonna go a little bit further, sorry. My intervals are going to be -infinity, less than x, less than -1 minus the square root of 2. -1 minus the square root of 2 less than x less than -1. -1 less than x less than -1 plus the square root of 2. And then that one to infinity, and I'm running out of room, so -1 plus the square root of 2. Sorry, that's why I was trying to move it down. I didn't do a good job. So f prime of x, what number could I plug in for this interval?
3.
-3. And then for this interval, what's a value from -2.4 to -1? Quote negative. She said a half, but not quite a half. -1/2 or 1.5. I know what you're trying to say. -1.5 is what I did here. I did 0 on this one and I did 2 on that one. I just picked something bigger than 1. Is what I was trying to do. Okay, so just watch those numbers. For f prime, you have less than 0, less than 0, greater than 0, greater than 0. What do those mean? The first one means decreasing to decreasing, so nothing happened. Decreasing to increasing, so going down to going up caused a minimum. I just leave it as -1 for a minute, and then I'll go back and fill it in. And then I had increasing on the end. My f of x was ln x squared plus 2x plus 3. Oh gosh, sorry. And I want to know what the value is at -1, and it's 0.6931.
Plug it into the f prime, would it be the same thing?
No. Remember, we were getting different values in our chart for all of that. Remember? Okay. All right, f double prime. When we plug in those values, we get less than 0, which is concave down. We get greater than 0, which is concave up, since that was a switch in direction. That's going to be a point of inflection. That's going to be at -1 minus the square root of 2, which is 1.3863. The next one stays concave up, but then the last one changes to concave down. So that change causes a point of inflection. And that point of inflection is at -1 plus the square root of 2. Which is 1.3863. Any questions? Again, you can graph those in your calculator, no big deal. Just to remind you of your homework. It's a whole 6 problems. I don't really care about the sketch. I care about your table. Okay, so I need to see the first derivative, the second derivative, your important points, and your table. It's only 6 problems I can do. Very good. All right. Get to work. So I have this problem